Partial fraction decomposition method, part 2. This time, let's work on item 4 and 5. Let's see this example. Let's say we have integral of 2x to the third minus 4x minus 8 all over x squared minus x times x squared plus 4 dx. Always the very first thing we have to check is whether the numerator is greater than the denominator or not. Here we have x to the third power. In the denominator we have x squared times x squared, which is x to the fourth. Since denominator is greater than numerator, we don't have to do any division. Now we have to decompose the denominator. We have to completely factor out. So this is equal to, for now let's use only numerator n of x. Here x squared minus x can be factored out, x times x minus 1. X squared plus 4 cannot be factored out, so we can leave it as it is. Now we're going to go to partial fraction decomposition method. We have 3 factors. For each factor we're going to assign a fraction. So this integral is equal to, for the first factor we have some constant over x, plus for the second factor, which is x minus 1, this is also linear, so we need another constant b. And for the third factor, which is x squared plus 4, this is quadratic factor, so we need some linear numerator. We assigned a b, so now we are at c, cx plus d. Now this fraction is equal to this fraction. Now we have to solve for a, b, c and d. Let's write our original question, 2x cubed minus 4x minus 8 over x squared minus x squared plus 4. Actually we can rewrite this as x times x minus 1, because that was the final form. So x times x minus 1 is equal to a over x plus b over x minus 1 plus cx plus d over x squared plus 4. Now we're going to multiply the whole equation by the LCD. So least common denominator, this is our LCD. So we're going to multiply everything else with x times x minus 1 times x squared plus 4. So if we multiply LCD with the first term, we obtain only the numerator, because this cancels that. So we obtain 2x cubed minus 4x minus 8 is equal to, and if we multiply it with the second term here, only x's cancel out, so it is a times x minus 1 times x squared plus 4. Plus, if we multiply b over x minus 1 with the LCD, only x minus 1 part cancels out, so b times x squared plus 4. And if we multiply the last term with the LCD, only x squared plus 4 part cancels out, so cx plus d times x minus 1. Now we're going to solve for a, b, c and d. So we're going to use the technique of giving value for x. Alright, for the first, let's say x is equal to 0. Let x be 0, then what happens? Then this goes to 0, negative 4x goes to 0, so negative 8 is equal to, if x is 0, then this is going to be negative 1. This is going to be 4. 4 times negative 1 is negative 4. It will be negative 4a here, plus bx times x squared plus 4 will be 0, because b times x, 0 times b, completely goes to 0. And c becomes 0. This x is 0, so everything is 0 here. So plus 0 plus 0. From this equation we can solve for a. Divide both sides on negative 4, so a is equal to 2. This time let x be equal to 1. If x is 1, then 1 cubed is 1 times 2 is 2, minus 4 times 1 is 4, minus 8 is equal to, we said x is 1, so 1 minus 1 is 0, so everything is 0 here. And 1 squared is 1, plus 4 is 5, and 5 times 1 is 5. This is going to be 5b, plus here we have x minus 1, which is 1 minus 1 is 0, so everything else is 0. So 0. So here we have 5b is equal to negative 10. So negative 10 is equal to 5b. Divide both sides on 5, so b is equal to negative 2. Let's go ahead and solve for c and d. For c and d, we will give again two values of x and then solve systems of linear equations. Let x be negative 1. X is negative 1, so let's substitute all x's with negative 1. So it's going to be 2 times negative 1 cubed minus 4 times negative 1 minus 8 is equal to, we know the value of a, it is 2, and x is negative 1, and here negative 1 squared is 1 plus 4 is 5. We know the value of b, which is negative 2, times x, which is negative 1, and negative 1 squared plus 4. We don't know the value of c, times negative 1 plus d, we don't know it either, times this x is negative 1, and negative 1 is negative 2. Now let's clean up and find the first system of equation. Negative 1 cubed is negative 1, times 2 is negative 2. This is going to be positive 4 minus 8. This is going to be negative 4 times 5, plus this is going to be 2, this is going to be 5, it's going to be 10, plus negative c plus d times 2. Here we have negative 10 plus 4 is negative 6. Here we have negative 20 plus 10. And here we have negative 2c plus 2d. And here if we merge the numbers, we have negative 10 here. Add 10 on both sides, so 4 is equal to negative 2 times c minus d, and divide both sides on negative 2, so negative 2 is equal to c minus d. Okay, this is our first equation. Okay, this time let x be equal to any value you would like. I would like to pick 2. If x is 2, our original equation is here, 2x cubed minus 4x minus 8. So 2x cubed minus 4x minus 8 is equal to a times x minus 1. We know a is positive 2, and x minus 1 times x squared plus 4, x squared plus 4, plus we have bx x squared plus 4, b is negative 2, and x is 2, and x squared plus 4 is 2 squared plus 4, plus we have cx, we don't know what the c is, and x is 2, cx plus d times cx plus d times x minus 1. X times x minus 1. Okay, instead of x, we placed 2. We know the value of a and b. Now we're gonna solve for c and d. Let's clean up this equation. 2 cubed is 8. 8 times 2 is 16. And negative 4 times 2 is negative 8 and negative 8. So this left hand side is 0. Negative 16, positive 16. Here we have 2 squared plus 4 is 8. And 2 minus 1 is 1. 1 times 2 is 2. And 2 times 8 is 16. Plus 2 squared is 4. 4 plus 4 is 8. 8 times 2 is 16. 16 times negative 2 is negative 32. Plus this is going to be 2, and 2 times this is 2c plus d, so it's going to be 4c plus 2d. And here 0 is equal to negative 16 plus 4c plus 2d, and if we add 16 on both sides, we get 4c plus 2d is equal to 16. Alright, this can be our second equation. And actually we can reduce this as well. If we divide error rating, if we divide all terms by 2, we obtain 2c plus d. If we divide each terms by 2, we obtain 2d, 2c plus d is equal to 8. Now equation 1 and equation 2 is helpful to solve for systems of equations. We have c minus d is equal to negative 2, c minus d is equal to negative 2, and we have 2c plus d is equal to 8. Now we can use one of the methods: elimination, substitution, graphing, or you can even use the matrix. But this is too simple, so let's use directly elimination method. Let's add them up, because negative d and positive d cancels out. So we have 3c is equal to 6. And from here, c is equal to 6 divided by 3, 2. And if c is 2, we can place it in one of the equations above. So 2 minus d is equal to negative 2. And we subtract 2 on both sides. Negative d is equal to negative 4, and multiply by negative sign, so d is equal to positive 4. Now we have a, b, c and d values. Now we can place a, b, c and d in our partial fraction decomposition that we prepared above here in this equation. Let me copy here and carry it down there. Our a value was positive 2, our b value was negative 2, our c value is 2, and our d value is 4. Our original question was integral of 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4 dx is equal to this right hand side. So it's equal to 2 over x plus, let's use direct and negative, negative 2 over x minus 1 plus cx. C is 2, so 2x, and d is 4 plus 4 over x squared plus 4 dx. Now we know how to integrate each term one by one. Now we're going to integrate this each term. So 2 over x is like 2 times 1 over x dx minus 2 times integral of 1 over x minus 1. We can separate this, so we can make it 2x over the denominator and 4 over the denominator. So plus integral of 2x over x squared plus 4 dx plus integral of 4 over x squared plus 4 dx, and we have dx here as well. Now we know the antiderivative of 1 over x is ln, so this is 2 ln, and in absolute value, because ln cannot be negative, minus, this is again ln because 1 over x, so it is, if you do u substitution, let u become x minus 1, so it's gonna be like ln of u times u prime, and derivative of x is 1, so it's going to be negative 2 ln of x minus 1. This is again ln. If you make u substitution for x squared plus 4, then du will be 2x dx, and if you place everything in terms of u, that 2x is cancelled out, so eventually you're going to get ln of x squared plus 4. For the last part of the integral, we're going to use the pattern of arctangent. So we should remember that 1 over x squared plus a squared dx is equal to arctangent of x. So we're going to make this integral look like 1 over x squared plus a squared. A is here some constant number, so this should be remembered. So here we're gonna do u substitution again. Let x be equal to 2u. Why 2u? Because if we square 2u, it's going to be 4u squared, and we can factor out 4. Okay, so we can pull this 4 in front of the integral sign, and 1 over, instead of x, we're going to write 2u, and we're going to square it, so it's going to be 4u squared plus 4. And here 2u is x, that implies u is x over 2, and if u is x over 2, then du will be 1/2 dx, which implies dx is equal to 2 du. So here, instead of dx, we're going to write 2 du. We can write du here and pull 2 here in multiplication form. And if we factor out 4, we're going to obtain here u squared plus 1, and that 4 can be pulled to the front. And if we clean up, we're going to have 2 integral 1 over u squared plus 1 du. This is exactly the pattern we wanted. So this is going to be 2 arctangent of u. And if we bring u back, u was x over 2, 2 arctangent of x over 2 is the final answer for the last integral.